Okay, so we are going to discuss power of sines and cosines. This is for integral calculus. So for sine u raised to m and cosine u raised to n, if m or n is an odd positive number, factor sine u or cosine u and use sine squared u is equal to 1 minus cosine squared u, or else factor cosine squared u equal to 1 minus sine squared u. If m and or n is an even number, use the identities cosine squared u is equal to 1/2 1 plus cosine 2u, or sine squared u equal to 1/2 1 minus cosine 2u. Okay, the first example, we have the integral of sine to the fifth 2 minus x dx. So if you are going to look at here, the exponent of your given, that is 2 an odd exponent. If you will have an odd exponent, you are going to factor out sine x and use sine x and use sine squared x equal to 1 minus cosine squared x. So for our given, that is sine to the fifth, okay, sine to the fifth u or sine to the fifth x, that is equivalent to sine to the fourth x sine x. Then you use sine squared x, so therefore you will have sine squared x squared, that is equivalent sine to the fourth sine x. Wherein sine squared x, that is equivalent to 1 minus cosine squared x squared sine x. So this one, so that's the reason our second line, that is similar to this one. Second line, 1 minus cosine squared 2 minus x squared. Then you will have sine u. So you will have sine 2 minus x dx. Then after that one, expand 1 minus cosine squared u. That's the reason we have 1 minus 2 cosine squared 2 minus x plus cosine to the fourth 2 minus x. Sine 2 minus x dx. Then after that one, multiply sine 2 minus x inside. So that's the reason you will have 1 times sine 2 minus x dx. You will have sine 2 minus x dx. Our u here, because you have one trigonometric function, only one, it's only sine. So for that case, if you will have only one trigonometric function, your u is 2 minus x. U is equal to 2 minus x. Derivative of 2 is 0. Derivative of negative x, that is negative dx. So you multiply, your du is negative dx, but then your dx here is positive, so you add negative, multiply negative outside. So that's the reason you will have negative here. Plus, okay, so this one, if we are going to multiply sine 2 minus x inside, you will have cosine squared sine 2 minus x, right? So you will have, that is the same, so we just factored out this one. So you will have negative 2 cosine squared 2 minus x plus cosine to the 4 2 minus x. So times, okay. So if you are going to look at here, our u, okay, I have a sample here outside. Negative 2 cosine squared 2 minus x multiply sine 2 minus x dx. Okay. So our n here, our n, that is 2. You will use u to the n here. Why? Because you have two trigonometric functions. If we have two trigonometric functions, that is u to the n. If we have one trigonometric function, your u is your 2 minus x. So if you have two trigonometric functions, that is cosine and sine, one of that is for du. So n here, your exponent, n is 2, u is equal to cosine 2 minus x. U is equal to cosine 2 minus x. Derivative of cosine, negative sine 2 minus x. derivative of 2, 0, derivative of negative x, that is negative dx. So if you are going to look at this one, that's the reason we have here for our du. This is our du. So our du is negative sine 2 minus x, negative dx. So negative, negative, that would become positive. So you don't need to multiply negative here. So that's the reason you have now a complete u to the n, du. So this one, okay, this is your u to the n. This one is our du. So our du is this one now. So you have now complete u to the n, then du. So you proceed to u to n plus 1 over n plus 1. So that's the reason you will have 2 cosine 2 plus 1, that is 3. So 2 cosine cube 2 minus x over 3 plus cosine to the 4th plus 1, so 5th. So cosine to the 5th over 5, 2 minus x plus c. So that is now the final answer. Okay, let's proceed to the next example. That is number 2. The integral of sine to the 4th 4 theta cosine cube 4 theta d theta. So the integral, if you are going to look at here, one of your exponent is odd number. So we have here, that is 3. So what we're going to do, factor out cosine. So we factor out 1 cosine. So what is left is cosine squared. Then transform cosine squared to 1 minus sine squared. So that's the reason you have 1 minus sine squared 4 theta. Then you will have cosine 4 theta d theta. Okay. After that one, multiply cosine to the 4th theta inside. So do with sine to the 4th theta inside. So that would become sine to the 4th theta, sine to the 4th 4 theta times 1. So sine to the 4th 4 theta times cosine 4 theta. So cosine 4 theta d theta minus the integral of sine to the 4th times sine squared. So sine to the 6th 4 theta times cosine 4 theta d theta. If you are going to look at here, we have two trigonometric functions. If we have two trigonometric functions, we will be using u to the n. So, if you have two trigonometric functions, you use u to the n du. Then, answer for that, u n plus 1 over n plus 1 plus c. So, for this case, our u is equal to sine to the 4 theta. Our n here, n is equal to 4. N here, that is equal to 6. So if you are going to look at here, n is equal to 4, that is your exponent. Then u is equal to sine 4 theta, derivative of sine, that is cosine 4 theta, derivative of 4 theta, that is 4 d theta. So this is now your du. So because your du is a form of 4 cosine 4 theta d theta, what you have is cosine 4 theta d theta. That is lacking of 4. So 4 is being multiplied to your du. So that's the reason you are going to divide outside with 1/4. So do it here. Our n is 6. Then u is equal to sine 4 theta. Du, that is derivative of sine, that is cosine 4 theta, derivative of 4 theta, that is 4. So 4 cosine 4 theta d theta. What we have here, if you are going to look at here, what we have is only cosine 4 theta d theta. That is lacking of 4. So du, we multiplied with 4. Then we are going to multiply outside with 1/4. This is now a form of u to the n, complete form of u to the n du. So once you will have a form of u to the n du, u to the n du, proceed to u to the n plus 1 over n plus 1. So that's the reason we have n plus 1, that is 4 plus 1, that is 5 over 5. times 4, that is 20. So that's the reason you have 1 over 20 sine to the 5th 4 theta. Minus, this is 6 plus 1, that is 7. So that's the reason you will have sine 7 4 theta. 1 over 4 times 7, that is 28. So you will have 1 over 20 sine to the 5th 4 theta minus 1 over 28 sine to the 7 4 theta plus C as your final answer. Okay, the next example, we have number 3, the integral of sine to the 6 y over 2 dy. Okay, for the ruling for an even exponent, so what we're going to do if we will have an even exponent. So it states that if m or n is an even integer, use identities. If that is cosine squared, you will have 1/2 plus 1 plus cosine 2u. For this example, we have, so for even identities, you use cosine squared u, that is equal to 1 over 2, 1 plus cosine 2u. Okay. Or if you will have sine squared u, that is 1/2, 1 minus cosine 2u. Okay. So we have, in our given here, this is to the 6. If that is to the 6, what will happen? That is an even exponent. So you use this one, squared. So that you can use squared, you will have sine to the 6. Okay, sine to the 6u. That would be equal to sine squared u. So that you will have 6 multiply 3 inside. Okay. So that's the reason you will have squared, then you will have 3. So sine squared y over 2 to the cube dy. 2 times 3, that is still 6. So if we are going to multiply, okay, multiply this by cube, you will have sine squared y over 2, transform that first to sine squared u, that is equal to 1/2, 1 minus 2, 1 minus cosine 2u. In our given, that is sine squared. So in our given, we have sine squared y over 2. So that will be transformed into 1/2, 1 minus cosine. Okay. 2 times u. What is our u? Y over 2. 2 times y, that is 2y. Divided by 2, so the u will have y only. Okay. That's the reason our transformation, that is equal to 1 minus cosine y. Okay, 1/2 outside to the cube. Then if you are going to expand 1 minus cosine y cube, okay, 1/2 raised cube, that is 1 over 8. 1 minus cosine y cube, you will have 1 minus 3 cosine y plus 3 cosine squared y minus cosine cube y dy. Okay. So we will have 1/8 integral of dy minus 3 over 8 cosine dy, okay, cosine y, okay, cosine y dy plus 3 over 8 multiplied by 1/8, 3 over 8 times, okay. If you are going to look at this one, this is cosine squared. The integral of cosine squared, that is equivalent to 1/2, 1 plus cosine 2u. So if you are going to look at here, your u is y. So you will have 1/2, okay, 1/2, 1 plus cosine, because this is y, then that is 2u, so 2y. You will have cosine 2y dy. Okay. So minus, okay, 1 over 8. 1 over 8 times, okay. This one is cosine cube. cosine cube, that is an odd exponent. So transform that one, factor out cosine, then proceed to cosine squared. Cosine squared, that is equivalent to 1 minus sine squared y. Okay. Then after that one, the integral of 1/8, that is 1/8y. Then here, the integral of 1, that is y. So you will have 3/16. Okay, if you are going to look at this is 1. 3/16 plus 1/8. Okay. 3/16 plus 1/8. So if you are going to look at this one, LCD is 16 divided by 16, that is 1 times 3, that is 3, plus 16 divided by 8, that is 2, plus 1 times 1, that is 2. So you will have 5/16. Okay, 5/16. So that's the reason you have here 5/16. And then the integral of cosine y dy, that is sine y. Then you will have the integral of cosine y dy, that is sine y. Okay. This is, so you have negative 3/8 integral of cosine y, that is sine y. So sine y. Then here you will have minus 1/8 sine y. Okay. So that's the reason you will have negative 3/8 minus 1/8. You will have negative 4/8, which is equivalent to negative 1/2 sine y. Okay. So that's the reason you will have, that is equivalent to negative 1/2 sine y. So this one. So next, that is sine 2y. Okay, this one. The integral of, okay, this one. The integral of cosine 2y. Okay, 2y. Cosine 2y, the integral for that is sine, okay, the integral for that is sine 2y. Then we will have 1/2. Okay. So I will show you the solution. You will have the integral of cosine 2y, that is equivalent to 1/2 sine 2y. Okay. 1/2 sine 2y. So your answer here is 1/2 sine 2y times, okay, you have 3/16 outside, times 1/2. That's the reason you will have 3/32 sine 2y. Okay, that's the answer. Here, okay, this one. If we are going to multiply sine squared y with cosine y dy, that is two trigonometric function. You have two trigonometric function. So, u to the n, you will use u to the n. So, here, that is, you will have sine squared y, cosine y dy. Okay, this one. So, you will have, u here is sine y. du is equal to cosine y dy. Okay. So that is now a complete form. U to the n. So therefore, that's the reason you will have n plus 1. So sine cube over 3. So sine cube over y. It's negative, negative, so positive, plus 1/8 times 3, so 24. So that's the reason you will have sine cube y over 24 plus c.